welcome back to my channel EduVibe, where we can today start with the grade 11 chemistry. And our first topic for the chemistry is the metal and the chemical bonding. So in this chapter, we will talk about the matter and their chemical bonding. They are the different types of bonding we will make, and the atomic structure is more likely with the related to the periodic table concept, which we made a separate video for this. In like we study about the periodic table, with what are the periodic table and what are the components for the periodic table. In this unit, we will firstly focus. Today's lesson is more focus on to the periodic table concept, which is again with the atomic structure. This unit. So firstly, we have the atomic structure, and we'll see that here we have the element boss, which is from the periodic table. So what is element boss? So this type of element boss we will see in the periodic tables. So each element boss on the periodic table communicates the information about the atoms of that element. That element boss, which is this is talks about, it communicates about the information that about the atoms of the element. So how it communicates? Like here we have that 26, the 26 is the what? Here the 26 is the atomic number for that particular element. And here we have that element and the element name. So in there we have a symbol of element, and we have the name of the element, which is iron over there. So this is our name and this is the symbol. And you also see that some numbers like this one, these one, and this one. So we know about all these numbers, like, so this one is electronegativity. This is the molar mass of that element. And these are the ions. Like some elements have the one ion, like only positive 2 or the negative 2, and but some ions have the two ions, like they are the stable ions, we call that stable charges, we call that them. And particularly they have the ions, like these are the positive ions for the iron. Some have the negative ions too. Next we have that, we know about this, like number of protons is equal to the atomic number. That atomic number is equal to the number of protons. Number of electrons which a particular element have, they are equal to a number of protons. So if we know the number of protons, so we also know that what is atomic number and what is the number of electrons, because they both are equal to number of protons. Next we have number of neutrons. Number of neutrons we use very less in this unit, but we know that they are equal to the rounded atomic mass number minus the atomic number. So what is atomic mass number? We'll know more about this later on in this unit. Move on to the atomic structure. So we know about the atomic structure from the previous lesson, that we got about the subatomic particles. Like we have three types of subatomic particles in one atom. First one is the protons, which are the positively charged. Second one is the neutrons, which are neutrally charged, are in the nucleus. So they all, like protons and neutrons, are in the nucleus, like in center of the atom. Electrons, which are negatively charged, they are surrounded the nucleus at the specific energy levels. So these all, like these red ones, are the electrons which are on the energy levels. So we have the infinite number of energy levels, or we can say the orbits. We have infinite number of orbits. Like we have 3 orbits in this for that particular element, and that orange one, and which I highlighted, are the electrons which are flow on that energy level or that orbit. Next one, we have the first energy level holds up to 2 electrons. Like if we see there, like in the first orbit, which is this, we have only 2 electrons in this. So it's the ability, it is the ability of the first orbit is to hold up only two electrons. But for the second and third, they are the ability to hold up out of they have a ability to hold up to 8 electrons each. As we see that in second orbit we have 8 electrons which they hold up, and after that if we left with more electrons, so we go with the third orbit. In third orbit we have only one electron because they after we have a left with no electrons because we have only one, but they have the ability to for the holding up to 8 electrons. Electrons in the outermost energy level, so the if we have like one electron in the outermost energy level, so so this represents the valence electrons, that how many valence electrons we have. So if we have the valence electrons of 1, so we know that in outermost energy shell, outermost energy level, we have only one electron on this, because we know about from the previous video that the valence electrons are equal to the group number. Next one is that electrons fill energy levels closer to a nucleus before occupying the higher energy levels. So before completing the higher energy levels, they firstly fill the energy levels which are closer to a nucleus. Then they go to the higher energy levels to fill them up. So we have an example for magnesium atom. So we have to make the energy level diagram for the magnesium atom and have to count at how many valence electrons does the magnesium atom have. For magnesium, how many electrons or how many protons they have? They have 16 protons. Why write protons? Because the protons are equal to the electrons and electrons are equal to atomic number. So atomic number is for magnesium is 12. So we also write the protons positive for this. Because in atoms, you have to know that thing that the if you have any atom like the magnesium atom, sodium atom, we have any atom, so in that case our protons are always equal to the new electrons. But if we have like magnesium ion, sodium ion, if we have the ion here, we have any ion of in the quotient, so we have to know that the in that case protons are not equal to electrons. Protons are not equal to the electrons. So why this will happen, we will talk more about this in later on. So next one we have to make the energy level diagram. So energy level diagram is like we have to write a magnesium, and in first orbit we have only ability to hold up 2 electrons, so we have 2 electrons in first energy level. In second orbit or in second level we have only 8 electrons to cover. We're done with the 10 electrons, so we left with only 2 electrons more. So in the third shell we only have 2 electrons. So to make the energy level diagram or to make the electron dot structure, which we'll learn more about in the next lessons, that how we make the electron dot structure. But I tell you the roughly that how we can make that. We have a first orbit over there, and in this orbit we have only ability to hold up 2 electrons. So we made 2 electrons. In the second orbit, we made the orbit and we have only ability to hold up 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. In the last one, in the last orbit, we left with only 2 electrons. We make only 1 and 2 electrons, and this is the magnesium. So this is how the electron dot structure look like. We will learn more about in this next lessons. So till then you will just know that how we can make the natural diagram like these ones. So next we have ions. So I've talked about that over there. Like we have also know about the ions. We only know about the atoms for now, but we know that there are 2 types of ions also in the periodic table. So first one is the cation and second one is the anion. So what are the cations? Cations are the positively charged ion. They are usually a metal. So the usually metals have the positively charged ion, which is called the cation, and that forms when an atom, usually a metal, loses one or more electrons in that case. But the anion are the negatively charged ion, and they form when an atom, which is usually a non-metal, gains one or more electrons. So we have an example again for this. If we have a beryllium ion. So if we made the energy level diagram for beryllium is Be, which has the number of protons they have 4. So we have to make the first energy level diagram for this, like Be over there. First we have 2 electrons, second one again have 2 electrons, and they complete the shell. So if we made the energy diagram for that ion, so we have to make like Be, we have 2 electrons. So either we always see the outermost shell. In that case we have outermost shell of 2 electrons. Either they lose that 2 electrons, either they gain the 6 electrons to complete the outermost shell, because the outermost shell holds up to 8 electrons. So either they gain the 6 more electrons to get stable and to get the 8 electrons, either they are lose the 2 electrons to be stable. So we have to do like a minimum value. Like if we lose 2 electrons, so it's good. But if we gain 6, then we need more energy to do this. In that case, we lose that 2 electrons to get stable on this. So we put the bracket on like this, and we put like 2 positive. So why we have 2 positive? Because when we lose 2 electrons, we gain the positively charged ion. So we know that they should be like in 2 positive like this, because we lose that 2 electrons to get the positive charge, which is 2 positive. So now they became the beryllium ion. For the next one, phosphide ion. Phosphide ion is have the like P, with P, and we have 15 protons, which is the atomic number for this. They have a 15 protons on this. So we have to make the energy level diagram firstly for this. Like P start with, so let's start with P. Firstly we have 2 electrons, then we have 8 electrons. Then how many electrons we want? With 5 electrons. We left with 5 more. Okay. So now we have to make like this. Again, we have 2 electrons, then we have 8 electrons. Now, here we have 5 electrons. So either they gain 3 more electrons to get stable, to get the 8 electrons, and the outermost shell will full. Either they lose their 5 electrons and get stable. So in that case, we have to gain that 3 electrons, because it's the minimum value, like 3 we have to gain, because if we want to lose the 5 electrons, we have to gain more energy, which is not possible. So in that case, we gained 3 electrons more to get 8 electrons in outermost shell, and which is a stable cell. We put that bracket on this and put 3 minus. So here we get the negatively charged ion to form an ion. So it's a 3 negative. So that's how you have to make that energy diagram for the ions. So next one we have the how to naming or writing the formulas for the ionic compounds. So we have to know that if we have like any ionic compound, so how can we naming, or how can we write that in that naming or writing the formula. So ionic compounds form when valence electrons transfer one atom to the another, resulting in the formation of cation, usually a metal, or the formation of ion, usually non-metal. So the valence electrons then transfer from one atom to another to form the cation and anion. So it's called the ionic compounds. And the cation and anion are attached to one another by charge. So they have to be in one charge. They have to be connected with one charge, forming a neutral ionic compound joined by the ionic bond. So we learn with the naming the rules. We have to name, how do we name that particular chemical name? How you can name in the particular chemical form. So to follow steps, we have to follow some steps like the name the cation first, name the positive ion first by using their element name, and then ion. Then name the ion by using the first part of the element's name. Only use the first part of element's name and changes the ending. And for an ion, we have to change the end. We have to change the end by ide, IDE, ide. If there is ion in polyatomic ion, if our ion is polyatomic, like from these are on the data sheet, data booklet of you, that these are all the polyatomic ions. They are a common polyatomic ion. If the ion is a polyatomic ion, so do not change the ending. So we don't need to change the ending of that. Let's do the examples to name the chemical names of that following chemical formulas. So do this. Firstly, we have to write that how this can be made. You know from grade 10th that if lithium, where the charge for lithium is 1 positive, and this is the nitrogen, and what is the charge for nitrogen is 3 negative. So when we do like crisscross for this, so then we get this. So firstly we have to name the cation, and cation is the positively charged. So this one is the positively charged, so lithium. So first one is our lithium. So right over there like lithium. And then we have to name the ion, which is this nitrogen. So for nitrogen we have to like write nitro, but we drop the last first, which is the nitrogen, and for this we have to replace this with ide, which is IDE, because this is nitrogen, not a polyatomic ion, so we have to like replace the last few words with ide. So from here we get lithium nitride. Okay, for next one we have nickel 2 and oxygen 3. So again we have to start with the cation. We know the nickel has, in their case, if we made that type of thing, so nickel has 3 positive because it goes like 3 goes for, because this 3 is for nickel, and that 2 is for that oxygen. So they have because we do like this intercrossing, that's why the charges are replacing. So if the nickel has 3 positive, so the oxygen is 2 negative. And if they, when they interchange, so we get Ni2 and 2O3. So to name this, we have to name first nickel. If we see from the periodic table, the nickel has the 2 charges. The nickel has 2 positive and 3 positive. But here we have 3 positive on this. So we know that we have to use this charge. So we have to know that how can we name that type of charge which have that 2 types of charge. For this, if there is a 3 charge, so we have to write in the brackets in the Roman number 3 like this, nickel 3, and we have oxygen, and we have to drop last 3 words with oxide. So we'll make the nickel third oxide. If there is a 2, so we have to make the 2 Roman for this. So next one is our vanadium. That V is the vanadium, and for the formula is V, and the vanadium has the charge of 4 positive on it. 4 positive. Why is the 4 positive? Because this is over 2. Because the sulfur has the charge of, where's the charge for sulfur? It's 2 negative. So if we have like this charge, which has a common factor for both, so we have to cut that charge like this from 1 and this is 2. So we get 2 positive for this. That's why we made like Vs2. So we write vanadium sulfide. But for vanadium, we have to write that 1,4. This 1,4 is for this one, because we have to know about that 4 positive we know now. So we have to write this. Straight for the example. So if we have the potassium nitrate, we know that potassium has K plus, and the nitrate, what is nitrate? Nitrate is a polyatomic ion. So if we go from here, we have nitrate over there, which is NO3 negative. So we made like our nitrate is NO3 negative. So this has positive charge, one positive, this one negative. So it's all both cuts out, and we get only KNO3, which is potassium nitrate. Next one is magnesium hydroxide. The magnesium is, we know, the magnesium Mg2 plus, and the hydroxide is again the polyatomic ion. Right over there. If for this we didn't cut anything, we didn't cancel anything, so we get Mg. So here we have not have to write like this. So this means that we have only 2 molecules of H, but we have the 2 molecules of O and H. So we have to put bracket over this, and then we have to put this too. This is the magnesium hydroxide. Next we have iron third oxide. So iron is Fe, and this is third, which is means that we have a 3 positive charge on it, and we have oxide, which is O negative. So here's the only thing we have to didn't cut anything from here too. So we get Fe2O3. So this one is the iron third oxide. Yeah, so this is all for this lesson. Learning made simple with EduVibe. Learn smarter but not the harder. Please like, share and subscribe to my channel. If you have any questions about this lesson, let me in comment section. So see you in the next video. Till then, stay connected with EduVibe.